So we will see how we can make use of 3D Slicer for converting medical image data to 3D models. So first we have Slicer 5.03 application here. So double click on 3D Slicer and it will guide us to a user interface. This user interface is divided into three parts: a top portion where we find different options, and a left hand side and right hand side. So we will see what are there, what are the things over there in the topmost parts. So here basically you can see different modules available in 3D Slicer. There are a number of modules available, and here we have a easy option for toggling between different modules and a backward and front forward buttons. And we also have the window settings where you can make use of different window settings based on users preferences. So usually we can keep it on the 4 up layout, so we can change the layout in different ways. So what are this layout actually? So this is nothing but, if you see, these are all different orientation of our city image. We have axial, sagittal and coronal views, different views of the city image can be seen here on these three windows. And also on the right window, we can see, in this blue window we can see the 3D models. And on the left side, what we are seeing is the options such as add data, add DICOM data, install slicer extensions, and different other options. So here basically we look for to import CT data, or else we can also make use of the sample data for this particular tutorial, or else we can import DICOM data if you have. So go to add DICOM data, import DICOM files, and I have a CBCT data here. Okay, so now the data has been loaded here in the directory. Now from there we need to load to our slice interface by double clicking the option. So once this is down imported or loaded into our 3D slice interface, we can see here, as I have already told you, what we are seeing in these three windows, that axial, sagittal and coronal views of the city data. All right. Now we have to go to volume rendering, go to modules and click on volume rendering, and then we can click on this volume rendering option. There is a eye symbol here, just click on it. So a 3D volume image will be appearing on the one of the windows. So you can center it using this option. Click on the center view, and now we can see the window is, the 3D model is centered at the window. Also, there is an option for maximizing the view. This will be using later on. So this I just show you how this model looks like now. So maximizing and minimizing, these are the options for maximizing and minimizing the layout. Okay. Now we can, what we do basically here is, we don't need the entire details. So we don't need the complete details from, we don't want to extract the complete details. So we will have some region of interest to extract. So for that, just click on inputs. You will find region of interest. So click on region of interest and create new ROA. Click on create new ROA as, and name it as mandible. I'm naming it as mandible. So once this is named, we can go to the presets. Click on bone, and we can preview the settings using the value which we selected. So here we have a plenty of options we can use for chest, bone, other soft tissues, or X-ray or MRI data. So these are different preset values which is available in 3D Slicer, and appropriate preset value you can select for our application. And this will show the preview of the object which we are going to create. So this has nothing to do with our extraction of the details, but this is just to get some basic idea and to visualize how our city data looks like. So this is This covered the first two part, that is the loading the data and 3D slicer interface introduction. Now, right now we are in volume rendering section or module. We have seen how this volume has been rendered using a preset CT bond values. Now what we need to do, we need to reduce our region of interest to for our particular study. So just click on enable. Now you can fit the volume, and what we do is we can reduce the region of interest, right? So using these yellow, green and red buttons, using different views, we can reduce it, or we can make our own region of interest. So basically this will help us to, so basically I am trying to extract the mandible portion. So we will exclude all other details which is outside this mandible area. So once this is done, now we will go to the converters and crop volume. I'll show once again. Go to converters and click crop volume. And this crop volume, we should note that the input ROI should be the one which is made already, that is mandible. Okay, we have named it in the volume rendering section module as mandible. So we need to select, we need to make sure that the input ROI is mandible now. And from there, now there is an output volume option. So in output volume option, create new volume as, click on create new volume as and type here, I can type here mandible cropped. Okay, just click on mandible cropped and click OK. And now we have to click on apply. So now the entire CT data is cropped into our region of interest. So to see that, we will, so please note that we started from the input volume. There's no series description. I mean, we have not named anything. So input ROI is mandible and output volume, that is cropped volume, is mandible. We have named it as mandible cropped. Now go to segment editor. So let us, before that, let us volume rendering, and let us turn off this volume. And now let us see on segment editor. So again, go to the modules and click on segment editor. Now select here in the master volume. Now this is known as the segment Asian module where we are creating label maps and creating the surface models. So just select master volume as mandible cropped. So now we can see that only the cropped portion or the region of interest is shown here in this 4 windows. Okay. Now let us go to the option here, that is add new empty segment. So click on add new empty segment and double click on the segment option here in this colored box. Just double click on here. If you double click here, what you will see is there are different threshold values available for different parts of the body. So if you see here, you have something for skin, artery, body fat, bone, capillary, cartilage, ligament, meniscus, muscle, nerve, organ, skin, tendon, etc. So let's find suitable thresholds for our application, that is mandible. So just click on this mandible and this is selected now, mandible, and now there is something called as threshold. So click on threshold. Once you click on threshold, you can see if you see the range of threshold is given. Okay, so how do we decide this? Where we need to keep? What should be the upper limit and lower limit? So usually bone will have a high threshold values, and hence we can create the upper limit as maximum and the lower limit as somewhere around 650, okay, or 630. This we have to do trial and error, and we need to find out which is the best suitable threshold value for our application. Say I'm clipping it on 632 and click on apply. Okay, and now we will see how the 3D model has been generated. Okay, just click on show 3D, click on show 3D, and you will see that the mandible is being created here, or the complete region of interest has been converted to a 3D surface model. So just click on this. I'll do one thing. Go to volume rendering and display ROI. Okay, let it be. So we don't need to display the ROI. Okay, so let's go back to the segment editor. Go back to segment editor. Yes. So now look at this. Now this is the region of interest with whatever we selected, and that has been converted to 3D model. Okay, and now we will see how this is Now we want to extract only the mandible portion, that is the lower jaw portion. So how can we do this? So for that, in this segment editor tool, we have various options. So one of the option here is erase option. So just use the erase option and we can just click on sphere brush and edit in 3D views and click on erase all segments. So if you click on this, what we will see is, okay, so let us do this. So I'll just make it smaller, and we don't need this particular portion. Okay, so using the erasing tool, just erase it off. So make sure that there is no connections. Okay, so what will happen if there is connection between uh, the sections, different section which you want to create separately, then that will result in a huge size file, and it will contain the region which are not in our interest. Okay, so that is why we always look for removing the connections. Okay, I think it's done almost now. Okay, now once this is over, so I have seen that there are some of the connections between the upper jaw and lower jaw, so I have removed such connections already, and I think here there are some connections. Okay, so that portion is also being removed. So now what we need to do is, we can, to separate this upper and lower jaw, we can go to the called island. There is an option called island, and you have something called keep island option. So how do we keep an option we can use is that just click on the keep island option, sorry, click on island option, and then click on keep selected island. Okay, so that means what does it mean is that still there are some connections between the upper jaw and the lower jaw. So again, let's go back to this and just we need to make sure that there are no connections present. Yeah, there is a connection. So let's go back to the erase tool and remove such connection. between the upper jaw and the lower jaw part. All right. Okay. Then we have something over here also. I think mostly it is done now. There are no connections present between the lower jaw and upper jaw now. So now what we need to do, go to the island option and just click on keep island. So remove small islands, and I think still there are some connections present between the lower jaw and upper jaw. So that is why this is not getting removed. So let us see, closely observe it. Anywhere the such connection is present. Yes, there are some connections. See this. So let us remove it also. Yes, let us remove this. Okay, remove that. Okay, remove it. Let us do this. Yes. Now go to island option and keep selected island and go back to the let us keep selected island and okay. Still, I think still there are some of the portion which is still there are some portion which is connected. So we have to find out that. Is here there is a connection. Okay, all right. And also let us see from this particular view. Okay, so I think it's almost done. And I'll go to keep island and keep selected island and click on this. Okay. elements, keep select to the element. I think still there are some connections available, so we have to carefully look at it again, that where that connection is present. Okay, so let us find out that some of the portions there might be. Right, here there is a connection. Okay, let us see that. Now go to islands. Right, so now you'll see that only the mandible portion is extracted. So now what we can do is we can go to the smoothing factor. We can go to the export option here. On next to the show 3D, there is an export option. So click on this export option and click on export to files. Now we will see there is an option called OBJ, NRRD, Nifty, etc. And we need STL file formats for 3D printing, and keep it file format as STL and select the destination folder. So I'll select this CBCT as the destination folder. Okay, and select folder and click on export. Okay, now you'll see that there is a STL file which is generated over here. If you see that the type of file on properties, this is an STL file, .stl file. So let's open and see this file. So just double click this. So once you double click, it will open your 3D model. So this is your 3D model, which is generated, 3D mandibular model, which is generated from medical image data. Okay, so this can be further 3D printed and you can modify, and you can section and you can see the model, or you can do other editing before going to 3D print the model. So this is the entire process of converting 3D model into converting medical image data to 3D